Imagine scrolling past a short video and needing a full second to figure out whether you're looking at a person, a stunt performer, or a machine. That used to be a special effects problem. Now it's a robotics problem. And here's the part almost nobody is saying out loud. The viral kung fu clips and eerily smooth housework demos are not just internet bait anymore. They're the visible edge of a stack of real engineering breakthroughs that suddenly makes humanoid robots feel less like a sci-fi prop and more like the next computing platform. If that sounds dramatic, stay with me, because by the end of this video you'll understand why humanoid robots suddenly seem so much more lifelike. What changed between flashy demos and measurable progress, why NVIDIA, Figure AI, and Chinese manufacturers are accelerating this race, and how the same artificial intelligence wave behind ChatGPT, OpenAI's mainstream breakthrough, Google's AI push, and Apple's on-device intelligence strategy is now colliding with the physical world. The big shift is simple to say, but hard to appreciate at first. For years, robotics looked impressive in clips and disappointing in reality. A robot could do one carefully staged task, like a magician doing the same card trick 10 times. It looked magical, right up until you changed the lighting, move the object 2 inches, or ask for one extra step. Now this is where things shift. The industry is moving from isolated tricks to reusable capability. Less puppet show, more operating system. Less one viral moment, more general-purpose behavior that can be trained, adapted, and measured. Think about the way smartphones changed when apps arrived. Before that, a phone was a fixed tool. After that, it became a flexible platform. Humanoid robotics is going through a version of that transition right now. The body matters, of course. Motors matter. Balance matters. Battery density matters. But the real unlock is increasingly software, data, and foundation models. The same broad idea that made large language models useful across writing, coding, and search is now being adapted for movement, perception, and physical decision-making. On March 18, 2025, NVIDIA launched Isaac GR00T N1 and described it as the world's first open humanoid robot foundation model for generalized humanoid reasoning and skills. NVIDIA also called it the world's first open, fully customizable foundation model for humanoid robots. That phrasing matters. Open, fully customizable foundation model. In plain English, NVIDIA isn't just selling one robot brain for one machine. It's trying to create a base layer that many robot companies can build on, tune, and extend. Here's what's interesting. That is a huge departure from the old robotics pattern. Historically, every robotics team looked like a custom garage project. Different hardware stack, different control logic, different training data, different simulation setup, lots of reinvention. Imagine if every car company had to invent roads, traffic lights, and driver's education before shipping a sedan. That's how fragmented robotics has been. A foundation model changes that because it gives everyone a starting map. And this is not just a slide deck idea. By May 18, 2025, NVIDIA said its open-source physical AI dataset contained 24,000 high-quality humanoid robot motion trajectories, with adopters including Agility Robotics, Boston Dynamics, Fourier, Foxlink, Neura, and XP Robotics. 24,000 high-quality motion trajectories may sound abstract, so let's translate it. That's like giving robot developers a giant library of recorded movement examples, how to reach, turn, grasp, reposition, balance, and recover, instead of forcing every company to teach every robot from scratch like it's the first toddler in history. Data in robotics is a lot like recipe testing in a kitchen. If you only cook one meal once, you don't really know whether the method works. But if you've tested thousands of variations across ingredients, temperatures, and timing, you build intuition that generalizes. That is what these motion datasets are doing for robots. They are compressing a massive amount of physical trial and error into reusable training material. This is also why the humanoid form factor, which many people still dismiss as a gimmick, keeps hanging around. In some environments, wheels are better. In some factories, robotic arms are better. But our world is built for human bodies. Doors, stairs, shelves, bins, carts, work tables, tool handles, apartment kitchens, warehouse aisles. It's all designed around 2 arms, 2 legs, and a torso that can reach and carry. A humanoid robot is basically a software gamble on existing infrastructure. Instead of redesigning the world for machines, companies are trying to design machines that can survive the world we've already built. Think of it like making a universal plug adapter instead of rewiring every building on Earth. That is expensive and hard, but maybe still cheaper than reconstructing every warehouse, store, hospital, and home around a completely alien machine shape. Now let's talk about the viral movement problem, because this is where public fascination explodes. When people say a humanoid robot looks scary or too real, they're often responding to timing more than appearance. Not just what it looks like, but how it moves through micro decisions. The hesitation before a grip, the weight shift before a turn, the tiny wrist correction when carrying an object. Humans are unbelievably sensitive to those cues. We can spot unnatural movement almost instantly, the same way you can hear when a song is slightly offbeat even if you don't know music theory. That's why recent demos hit so hard online. It's not only that robots can move, it's that they are starting to move with enough fluidity that the old category labels begin to fail. Your brain stops saying machine and starts asking a stranger question, who taught this thing body language? The answer, increasingly, is a blend of simulation, teleoperation, imitation learning, reinforcement learning, and foundation model-style training. In simple terms, developers let robots practice in virtual environments, learn from human demonstrations, optimize for successful outcomes, and transfer those skills into the real world. It's a little like flight simulators for pilots, except the pilot is also learning how to pick up a box, open a door, and not fall over on a polished floor. And unlike text AI, robotics has no tolerance for vibes. A chatbot can hallucinate and still sound convincing for a while. A humanoid robot cannot hallucinate gravity. If it guesses wrong about weight distribution, friction, or hand placement, it doesn't generate a weird paragraph. It faceplants into a table. That brutal feedback loop is why progress in robotics has felt slower than progress in pure software AI. Physics is the ultimate fact-checker. This is where figure AI becomes especially important. Figure has become one of the clearest examples of the field moving from cinematic promise to benchmarked improvement. On June 7, 2025, Figure AI reported that its Helix logistics benchmark improved to 4.05 seconds per package, about 20% faster than roughly 5.0 seconds before. Correct scan orientation also rose to about 95% from about 70%. Those numbers deserve more attention than any backflip clip. Why? Because this is what real capability looks like in industry. Not a one-off wow moment, but repeated throughput and accuracy gains in a workflow companies actually pay for. If a robot in logistics handles packages faster and aligns scans correctly far more often, that starts touching labor economics, shift design, warehouse layouts, and deployment math. It changes planning spreadsheets, not just social feeds. Use an everyday analogy here. Going from around 70% to about 95% correct scan orientation is like going from a friend who constantly loads the dishwasher wrong to someone who almost always puts everything in the right place without being told twice. At first that sounds small. In a high-volume operation, it's enormous. The difference between frequent intervention and mostly hands-off performance is where automation becomes useful instead of exhausting. And the speed gain matters too. 4.05 seconds per package versus roughly 5 seconds may seem tiny if you imagine one box on a table, but scale it across thousands of packages, multiple shifts, multiple facilities, and suddenly small gains turn into meaningful operational leverage. This is the same reason Apple squeezes tiny efficiency gains from silicon every year, and Google keeps shaving milliseconds off search and ad systems. At scale, the decimals become strategy. That brings us to a deeper point. The robotics race is starting to look less like a hardware novelty contest and more like the smartphone wars or cloud wars. Everyone sees the device, but the real battle is in the stack. Who controls the models? Who controls the data pipeline? Who controls simulation? Who controls developer tools? Who turns one customer success into a repeatable platform? NVIDIA clearly wants to be foundational in that stack, and that should not surprise anyone who's watched its role in the AI boom around ChatGPT and OpenAI. In the language model era, NVIDIA became the arms dealer of modern AI because training and inference needed its hardware and software ecosystem. In robotics, it is trying something similar, but with an extra layer, not just compute for thinking, but platforms for embodied intelligence. It wants to be there when robots learn to reason, move, perceive, and coordinate. Now this is where things shift again. Once you frame humanoid robotics as the next platform battle, the company list gets more interesting. OpenAI is relevant because it normalized the idea that foundation models can generalize across tasks. ChatGPT made that idea legible to the public. Google is relevant because its AI and robotics research has long explored multimodal models that connect language, vision, and action. Apple is relevant even without a humanoid robot because Apple has trained consumers to expect intelligent systems that run with polish, privacy, and seamless hardware-software integration. If humanoid robots ever become consumer-adjacent, the Apple question won't be whether it can make one tomorrow. It will be whether the market eventually demands the same trust and usability standards people expect from phones and wearables. Right now, most humanoid deployments are not aimed at your living room. They are aimed at places where labor is repetitive, environments are already structured, and return on investment can be measured. Warehouses are the obvious example. Manufacturing support roles are another. Internal logistics, material handling, repetitive transport, bin picking, sortation, line-side delivery. These are less glamorous than internet demos, but they are the beachhead. Think of the factory or warehouse as the robotics equivalent of the enterprise office in early computing. New systems often enter through controlled, high-value settings before they become consumer-friendly. PCs reached offices before they transformed homes. Cloud software reached businesses before normal people casually depended on it. Even early AI assistants landed in productivity tools and customer support before showing up in everyday hardware. Humanoid robots may follow a similar path. This is one reason Figure AI's funding matters beyond the headline number. On September 16, 2025, Figure AI said it had secured more than $1 billion in Series C funding at a $39 billion post-money valuation. That is not a niche bet. That is capital markets saying this category could become enormous if execution continues. Money alone does not guarantee success, of course. The tech industry is full of expensive disappointments, but funding at that scale buys time, talent, compute, manufacturing capacity, partnerships, and the ability to survive the brutal middle stage between prototype and production. Brett Adcock said Figure's Brookfield partnership would help unlock general-purpose humanoid robots. That phrase, general purpose, is doing a lot of work. It means investors and operators are not just chasing one robot that can do one warehouse trick. They want a machine and software system that can transfer skills across environments, the way a laptop runs more than one app. The dream is not a robot appliance. The dream is a robot platform. Still, ambition is one thing. Manufacturing is another. And this is where China enters the story in a very serious way. On April 9, 2026, TrendForce said China's humanoid robot output is expected to rise 94% in 2026, with Unitree and Agibot projected to capture nearly 80% of the market. That statistic changes the conversation because it points from prototype culture towards scale culture. A 94% output rise is not just more robots. It suggests faster iteration, stronger supply chain alignment, and the possibility that humanoid production could begin following the familiar China hardware playbook: rapid manufacturing learning curves, aggressive pricing pressure, ecosystem clustering, and accelerated feature diffusion. We have seen versions of this in smartphones, EVs, batteries, drones, and consumer electronics. Once output climbs, everyone else has to race not just on innovation, but on cost and speed. Here's an analogy. Early humanoid robotics today feels a bit like early electric cars felt before production really ramped. The first story was spectacle. Fast launches, flashy clips, giant promises. Then the real story became supply chains, battery costs, factory throughput, software updates, and who could actually ship. Humanoid robots may be entering that second phase now. Public perception, though, is lagging and racing at the same time. Lagging because many viewers still assume all the clips are fake, stitched together, or heavily remote controlled. Racing because social media can take a narrow capability and make it feel universal overnight. A robot folds one shirt, and the internet starts debating robot roommates. This mismatch between visible theater and actual capability is why coverage often feels confused. So what can these systems really do today? In the best cases, they can execute increasingly robust manipulation and movement tasks in semi-structured environments. They can walk more naturally than before. They can handle bins, packages, and object transfers with greater consistency. Some can respond to higher-level commands rather than brittle line-by-line programming. Some are improving through simulation-backed training loops rather than only hand-coded routines. That is meaningful progress. It is not the same thing as dropping a robot into a chaotic family kitchen and expecting it to cook dinner while your dog runs through the room and your toddler changes the plan every 30 seconds. That gap matters. And it brings us back to the uncanny feeling people get from these machines. The scariest thing about humanoid robots is not actually that they resemble us. It's that they expose how much silent competence we take for granted in ourselves. Picking up socks from the floor sounds trivial until you ask a machine to understand cloth, balance, reach, trajectory, finger pressure, obstacle avoidance, and recovery when the sock slips. Walking into a room is easy until you map every tiny decision hidden inside that action. In that sense, humanoid robotics is becoming a public masterclass in embodied intelligence. It reveals that intelligence is not just answering questions, which is why the ChatGPT comparison is useful but incomplete. A language model can write a plausible summary of how to make coffee, A humanoid robot has to locate the mug, estimate weight, avoid spilling, adjust grip force, navigate around a chair, and recover when the counter is cluttered. Knowledge in words is one layer. Competence in atoms is another. This is also why companies like Google and Apple loom in the background of the conversation, even when they are not the ones posting the robot dance clips. Google has spent years building systems that connect perception and action, and it understands ecosystems. Apple understands something equally important: trust. If robots eventually leave industrial settings and enter mainstream daily life, people will care about reliability, privacy, local processing, safety boundaries, and integration with the devices they already own. A future household robot may need a relationship with your calendar, your smart home, your voice assistant, and your personal preferences. That turns humanoid robotics into not just an AI question, but a platform governance question. And yes, OpenAI matters in that broader context because it shifted investor and public belief. Before foundation models went mainstream, many people viewed general-purpose AI as a lab curiosity. After ChatGPT, the world saw what happens when one base model can be adapted to many uses. Robotics founders took note. Investors took note. Entire product strategies changed. The embodied version of that idea is now unfolding in public. But we should be careful not to flatten all intelligence into one bucket. A robot that sounds smart is not necessarily physically capable. A robot that moves beautifully is not necessarily safe, robust, or economically viable. The next big winners will likely be the companies that align all three: cognition, control, and cost. In everyday terms, they need the brain, the body, and the business model. Safety will become the next huge dividing line, not because it sounds responsible in a press release, but because deployment depends on it. A warehouse can tolerate some awkwardness if output gains are compelling. A home cannot tolerate much. A robot in a family space has to be less like an experimental forklift and more like an invisible appliance with limbs. That requires better perception, smoother fail-safe behavior, stronger edge case handling, and likely a lot of on-device or low-latency inference. Nobody wants a cloud timeout while a robot is holding glassware. This is where the broader AI ecosystem could cross-pollinate in powerful ways. Apple's push for efficient on-device intelligence, Google's multimodal AI research, NVIDIA's physical AI stack, and the general-purpose model mindset accelerated by OpenAI all point toward the same long-term idea: intelligence that understands context, acts quickly, and adapts across tasks. Humanoid robots are simply the most dramatic expression of that trend because the output is visible in physical space. Now here's the bigger reveal. The most important question is no longer, can a humanoid robot be made to look real on camera? Clearly, yes. The more consequential question is, can these systems become boringly useful? Can they show up every day, do repetitive work safely, improve over time, and justify their cost without needing perfect conditions or human babysitting? That is the threshold that separates spectacle from infrastructure. And the evidence we now have suggests the field is inching toward that threshold faster than many people expect. NVIDIA's March 2025 GR00T N1 launch signaled a foundation model approach for humanoids. Its 24,000 trajectory dataset update by May 18, 2025 showed that the training pipeline is becoming richer and more open. Figure's June 7, 2025 Helix benchmark improvement showed concrete gains in speed and package handling reliability. Figure's September 16, 2025 funding round showed investor conviction at extreme scale. TrendForce's April 9, 2026 projection of 94% output growth in China, with Unitree and Agibot approaching an 80% share, showed that manufacturing momentum is building too. Put those together and a pattern emerges. Better models, better data, better benchmarks, bigger capital, faster output. That is not a random set of headlines. That is the shape of an industry moving from demo era into platform era. So are they robots or real people? For now, the answer is still easy in person and harder on your phone. But the reason it feels uncanny is not some sci-fi mystery. It's engineering convergence. Computer vision got better, motion control got smoother, training data got deeper. Simulation got more useful. Hardware got more capable. Capital got larger. And social media gave the whole thing a theater stage where every incremental improvement suddenly feels shocking. The internet sees a scary human-like clip and asks whether robots are becoming people. The smarter question is whether machines are becoming competent enough to share more of our physical workload. That is less cinematic, but much more important, Because if that answer becomes yes in logistics, manufacturing, elder support, hospitals, or household assistance, then humanoid robots stop being content and start becoming economics. And once economics takes over, the pace can change very quickly. Just ask anyone who underestimated smartphones, cloud computing, electric vehicles, or generative AI. At first, they looked like isolated curiosities. Then, the underlying stack improved. Then, the use cases multiplied. Then, the world quietly reorganized around them. Humanoid robots are not fully there yet. They are still early, uneven, and often overhyped. But here's what's interesting. For the first time in a long time, the hype is being chased by real numbers instead of only cinematic promise. That should get your attention. If you want more forward-looking breakdowns like this, hit like, subscribe to AxonWire, and check the description box for links to the tools, companies, and references mentioned in this video. Because the next time a robot clip makes you ask whether it's fake, frightening, or futuristic, you'll know the real story is deeper than the demo and much closer to your world than it appears.